Welcome to Surviving Statistics Lesson 1. I have lots of statistics videos out on YouTube, and this is a new series that's a little bit updated, and it's also based on my book, Surviving Statistics, A Professor's Guide to Getting Through. So in this first lesson, we're going to talk about the definition of statistics. We're going to talk about the difference between populations and samples. We'll talk about the difference between descriptive and inferential statistics. We'll talk about some measurement scales, nominal, ordinal, interval, and ratio measurement scales, just to get you started in your journey through learning statistics. So let's start by what is statistics. There's actually two different ways to look at statistics. First off, statistics is the science, which is a branch of mathematics that deals with collecting, organizing, analyzing, presenting, and interpreting data. And data is typically mass quantities of numbers. And we're trying to interpret that data most often to make decisions and help us understand things. We could also say that statistics are organized, analyzed, presented, and interpreted quantitative data or numbers. So the definition, though, that I like best is statistics is the process of producing useful information from raw data. So let's look at some examples of what I'm talking about here. Here you see some raw data. There's lots of numbers here, but you really don't know anything about these numbers other than there's a lot of them looking at this information here. What if I showed you this? What if I took that same raw data and summarized it and gave labels to what I've summarized, and maybe that data is actually telling me the number of patients that I surveyed in a hospital, the average age of the respondent, the average days that the respondent was sick, and the average days that the respondent spent in the hospital. This makes a lot more sense. So look at these two tables, the raw data and then the summarized raw data. And of course, the summarized raw data is a lot easier to understand, and that's how we use statistics. Notice we have some counts and some averages in here. Okay, so statistics is the process of producing useful information from raw data. And why we do that? Well, we might do that for one of these two reasons here. There's two categories of statistics that you'll need to be aware of. As you're moving through my workbook or through your class, one of the first things you'll learn about is descriptive statistics. And descriptive statistics just describe the data, and that could include things like counting, or averages, and it also moves up into complexity into things like variance, standard deviation, and skewness. Now, don't worry about those numbers. Hopefully you've already been introduced to some of that in your prior math classes, but if not, we'll get through them as we go through additional lessons in surviving statistics. All right, the second category, first we had descriptive statistics that just simply describe the data. The second category is inferential statistics. Now, inferential statistics result in inferences or predictions or estimates. And here's some examples of inferential statistics being used. We might use it to try to predict an election, and so we might make a statement based on inferential statistics, such as the governor has a 97% chance of being reelected, or the Red Sox have a 2% chance of winning the World Series this year, or a patient with stage 1 skin cancer has a 99% likelihood of being cured. And so inferential statistics are very, very important for the introductory statistics class that you're likely taking here. Descriptive statistics help us describe it, but inferential statistics help us predict what might be based on the statistical information that we get from our raw data. So again, inferential statistics is important because researchers and also students in statistic courses and also students that are preparing for advanced degrees, master's degrees, and even bachelor's degrees and PhDs will make inferences based on statistical analysis, and they're going to do that trying to estimate for a population. So in other words, we're trying to predict who's going to vote for the governor. And we would say that he has a 97% chance of being reelected based on what the population is telling us. Well, we gather the information about populations from samples. And so we're going to be talking a little bit about the difference between a population and a sample. A population is every person or object or item in the group that you are interested in. So as an example, a population could be quite small, but it also could be quite large. One example might be every car in a Walmart parking lot. That is a population because the key word there is every. Every shopper in the store would be considered a population. Every person living in New York City, or every person in the United States, all of these are populations. Now looking at the illustration on your screen here, all of the cubes in this illustration could actually be a population as well, because again, it's all or every. So again, populations can be small, but they can also be very, very large. A sample, on the other hand, is a representation, a representative portion or a subset of the population. So in the figure that you see on your screen here, I have 15 cubes as a population. All 15, not cubes, excuse me, but all 15 of the symbols would be a population. Now I've taken a subset of 3 of the 15, and that in this case is going to represent a sample. Now inferential statistics make predictions based on samples that have been gathered from populations. Now using the illustration, with the sample that I've gathered, happy faces represent 1/3 of the sample. Now using inferential statistics, I might make the assumption in this case that of the population, 1/3 of those might be happy faces. Well, that is not really correct, because if you look, that is not an accurate representation. And so we have a little bit of a problem sometimes with accuracies in samples representing populations. But we'll talk about that as we get further in surviving statistics. So why do we work with samples? We've also seen that they may lead to inaccurate inferences, as in the case with the happy faces there. But we'll talk about that a little bit more. But let's talk about why we really do work with samples, because they really do work if it's done right. A sample can lead to a very, very accurate inference of the population. So we'll talk about the potential inaccuracies. We have some fudging. I know that's a bad word to use in a math class here, but we fudge a little bit sometimes, or we adjust. We have what's called a margin of error, and I'm sure that you've probably heard that. If you've ever paid attention to political races, there's always a margin of error. But we'll talk about that as we get a little bit further here. So why do we sample? Well, first off, one of the reasons that we sample is surveying an entire population could be very expensive. What if we're trying to do a census of every person living in the United States? I mean, there's what, 350 million people here roughly? That would be extremely time-consuming and expensive, and even the U.S. government only does it every 10 years. Number 2 reason why we work with samples is surveying or testing can be destructive. For example, what if you're concerned about quality and in a candy bar factory? Well, one thing that you could do is that you could unwrap every candy bar and taste it and see if it was okay. But you know, half-eaten candy bars are really hard to sell. Nobody wants one with teeth marks in it. Or what if you work for a fireworks company? You can't test every firework or you wouldn't have anything to sell. So that's another reason why we use samples instead of the population. We survey a representative sample of the population. Well, when we survey, we're going to be working with variables. Now, variables are what we're asking, the questions that we're asking the sample. And these are values and characteristics are called variables. For example, if I ask someone how tall they were, how much they weighed, what their favorite color was, what their GPA was, those are all variables. Now there's 2 broad categories of variables that we need to introduce you to: quantitative and qualitative. You'll hear those again and again in your statistics course and also in my Surviving Statistics book. So a qualitative variable are variables that are not numeric, such as, what is your favorite color? What do you do for employment? What's your favorite video game? Those are very hard to quantify. Sometimes, though, we can add or assign a number to qualitative variables, but sometimes there's more data than we are able to do that with. For example, if I ask you, why did you go to college, or why are you studying statistics, that's probably going to be more than a one-word answer, and those are sometimes hard to do statistics from. Okay, quantitative variables are really what we're going to be dealing with more often in statistics. Quantitative variables are numeric, and of course we can do statistical analysis with those quantitative variables. So for example, some quantitative variables might be a couple that we mentioned before: height, weight, a test score, and also your annual income. Now, again, like I said, since statistics is going to be dealing with numbers, we can expect to be working throughout your statistics course, and also in my textbook, more with quantitative variables than qualitative variables. Well, we can do, like I mentioned, we can use qualitative variables sometimes in statistics by converting them to numbers. So for example, with the example that you see here, and also you'll find in my textbook here, we could assign a value to your favorite color. And so if I ask you what your favorite color is, you could you choose red, blue, green, purple, or yellow. I'm just giving you that standard set list there. But I could assign a value of 1 for red, and 2 for blue, and 3 for green, and so on here. And so therefore I could count how many ones, but some of these are not going to make much sense. For instance, if I ask you to give me the average of your favorite color, that really wouldn't make any sense if I said that the average favorite color is blue and a half. Of course, that doesn't make any sense. Okay, so these are categorical variables if we can convert them into numeric data. So quantitative variables, again, will be two different categories. We have discrete, and we're also going to introduce you to continuous. But discrete variables, another term you need to be familiar with, result from counting. So the number of students in a class, the number of devices connected to the internet in your home, the number of patients, the number of in a hospital, the number of cars in Walmart, you can count those. And so if they can be counted, 1, 2, 3, 4, 5, and so on, we would call that a discrete variable. Now, of course, not all variables are going to be discrete. And so then we also have continuous variables, and continuous variables are variables that are measured, and they can actually assume any value within the range. So for instance, if I ask a patient or weighed a patient as they came into the hospital, they might be 102 pounds, 102.3, 102.6. Again, it could be any particular value. The amount of time it takes a student to complete an exam, I really have a hard time counting that. It might be 5 minutes, 6.5 minutes, 32 seconds. The amount of gas in your fuel tank is also continuous. It can range anywhere from full to empty. And of course, the remaining battery life on your smartphone. That's a continuous variable, a variable that can take any value within the range. So again, your car could be a 1/8, it could be 0.75 full, 0.78 full, any value within the range of full to empty. That is a continuous variable. Well, we also have to get this a little bit more confusing as we're talking about all of our definitions here in the beginning. But we also have different measurement scales that we'll use for quantitative variables. So first off, we have the category of discrete and continuous that we just talked about. Now we're going to be talking about 4 different categories or measurement scales that we put these in. So let's talk about 2 variables: the heights of basketball players and a favorite color. So counting how many people like red, that would be okay, but as I mentioned before, trying to take an average of their favorite color would make no sense whatsoever. On the other hand, though, the average height of a basketball team would be very, very helpful. So the 4 scales that we're going to be discussing are nominal, ordinal, interval, and ratio. The first scale that we're going to talk about in a little bit more detail is the nominal scale. And nominal scales are used for data that is assigned values, but those values really don't equate to anything that can be tangibly ordered. In other words, think about your favorite color. You may really like blue, and somebody else may really like red. Now we could assign with our turning qualitative variables into quantitative variables, we can assign a number to red and blue and so on, but simply because red is assigned the value of 1 and yellow is 5, it does not mean that 1 is more valuable than yellow. And so really we can't do much data analysis with data that's using a nominal scale. We can count it, we can summarize how many preferred blue, how many preferred red, and we can compute some percentages, but other than that, that's about all we can do with nominal scales. Ordinal scales are a little bit more useful, and in this case we rank things in order, but we really can't determine the difference between the values. In other words, the example here in my textbook is ice cream. You may really like vanilla ice cream, and you may rank that with 1 as your favorite, and then you like strawberry as 2, but we really can't determine how much more you like vanilla versus strawberry. Now, with an ordinal scale, we're very limited again to what we can do. We can simply count and maybe compute some percentages. So not a lot of statistical analysis with ordinal scale. But remember, an ordinal scale is we can simply say, yes, it's just red, blue, green. With a nominal scale, assigned a value. But in this case, we can say, yeah, I really do like vanilla, or whatever team better than the other. Okay, an interval scale. This is a little bit more important as far as statistical analysis. With an interval scale, the data is measurable and the differences are meaningful. So in other words, the typical example we like to use is shoe sizes. There is a difference between size 1 and size 2. Temperature, the same thing. Now, what makes the interval scale a little bit unique is that it can have a 0 on it, but that the 0 really does not mean the absence of anything. Think about the thermometer. That's kind of the classic example of the interval scale. 0 degrees Celsius or 0 degrees Fahrenheit does not mean the absence of temperature. And the same is true with clothing. There are dress sizes and shoe sizes that use a scale size of 0. But if a shoe has a size of 0, it doesn't mean there is no shoe. It's simply a value that is assigned, but there is a measurable difference between size 0 and size 1. The ratio scale is very similar to the interval scale, but the difference is 0 really does mean 0. So, for instance, we use things with the ratio scale that we can count. If I were asking how many students attended class, and I told you that there were 0 students in class today, well, that would definitely mean that there were no students. That would be an empty classroom. And so a ratio scale is, again, measurable differences between each of the values, but 0 really does mean 0. Well, let's go ahead and summarize what we've talked about in this particular lesson. So, some of the highlights. I like to define statistics as the process of collecting, organizing, analyzing, presenting, and interpreting data. Remember, descriptive statistics summarizes and describes the data. Inferential statistics attempts to generalize and predict or estimate something about the population, and of course they do that by using samples. And while a population includes all the elements, a sample is a subset. Why do we use samples? Well, samples are less costly and practical than having to survey every member in the population, and it saves damaging or destroying every member of the population. And we will learn as we continue on that samples can indeed give us a very accurate estimate of a population. Then we talked about variables, and variables are the characteristics of what we're measuring. They're things like height, favorite color, whatever it is we're happening to be measuring, and then analyze our variables. Qualitative variables are non-numeric variables such as favorite color and gender, whereas a quantitative variable is a numeric variable. We're going to be dealing most often with quantitative variables in statistics, and so we break that down into 4 different scales. Nominal, where the values do not equate to relative worth or ordinal. They are ranked in a meaningful order, but we cannot determine the value or the difference between them in a numeric way. Interval is meaningful and has measurable differences between the values, but 0 does not really mean the absence of a value. Ratio, same as interval, it has meaning and measurable differences between the values, and 0 truly means 0. Alright, well, hopefully we'll stick around for lesson 2. Remember that my workbook, my textbook, is available on Amazon.com. You can also find some statistical calculators on my website, luthermaddy.com.